So our last example here, it's a definite integral. We've got a power of z times a log function here. And so I look at that, and if you've got a power of z times a log, you're usually using integration by parts. But here, this is the cubed root of z. So if we rewrote this here, this would actually be integral 1 to 2, and this would be z to the 1/3 times natural log of z dz. So if this was a whole number power like z squared, z cubed, we'd be using integration by parts, but I don't like that z to the 1/3 power, that fractional exponent. Because if you differentiate that, it's never going to go to 0. It doesn't get simpler when you differentiate it. It is easy to integrate, and then you can differentiate this one. So we can still try integration by parts, except this will be the piece that we differentiate. So how about, let's use u is going to be natural log of z, and then dv is equal to z to the 1/3. Then du here will be the derivative, which is 1 over z dz. That's a simpler derivative. And then our v, add 1 to the exponent, so z to the 4/3 power, 1/3 plus 3/3. And then divide by 4/3 means multiply by 3/4. So we do the diagonal product minus the integral of the last row. So this will be 3/4 z to the 4/3 times ln of z minus integral of the product in that bottom row. So 3/4 z to the 4/3 times 1 over z dz. And then let's see, this z will cancel out 3/3, so that'll be back to 1/3. And then the 3/4 we can move outside. And then we can just do power rule. So this will be 3/4 z to the 4/3 natural log of z minus 3/4. And then we've got z to the 1/3 power. So add 1 to 1/3, you get z to the 4/3. And then divide by the new exponent, divide by 4/3 means multiply by 3/4. So you get another factor of 3/4. And then this is a definite integral. So we are going to take this whole thing, now that we've got our antiderivative, and we'll evaluate from 1 to 2. So actually I should have done this. Integral 1 to 2, and then 1 to 2. So plug in 2 all the way across, plug in 1 all the way across, and subtract. So 3/4 times 2 to the 4/3, natural log of 2, minus 3/4. Well, actually, this 3/4 we can pull out there with that one. This will be 9/16 if we multiply them. So 9/16, and then times 2 to the 4/3. And then minus, same thing, plugging in a 1. So if we plug in a 1 here, 1 to the 4/3 is 1. Log of 1 is 0. So that part's going to drop out. So 3/4 times 1 to the 4/3, natural log of 1. And this is 0, so this whole first term drops out, minus 9/16 times 1 to the 4/3, so minus 9/16 times 1 to the 4/3 power, which is just 1, so 9/16 times 1. So we have a numerical answer. It's not pretty, but we have a numerical answer. Integration by parts for a power times a transcendental function. Natural log, e to the x, cosine, sine, cos, sinh, etc. Now, if this was cube root of z times sine or cosine, I'll just mention there, you'd actually need to do a rationalizing substitution before you would be able to do integration by parts. On this one, we didn't need to because we weren't differentiating the z portion. We were differentiating log of z.